Need to expose static files, simple text notices, or directory listings as resources in your FastMCP server without writing custom functions for each. You'll see how to directly register predefined resources using concrete classes like FileResource, TextResource, and DirectoryResource. This approach bypasses the need for decorator functions when you just want to serve existing files, fixed text, or directory contents as MCP-accessible resources.
From PassLib, import Path. From FastMCP, import FastMCP. From FastMCP resources, import FileResource, TextResource, DirectoryResource. MCP equals FastMCP. Name equals data server. #1, exposing a static file directly. README path equals path/README MD. Resolve. If README path exists, #use a file //URI scheme. README resource equals FileResource. URI equals F-file //README path as POSIX. Path equals README path, #path to the actual file. Name equals README file. Description equals the project's README. MIME type equals text/markdown. Tags equals documentation. MCP, add resource, README resource. #2, exposing simple predefined text. Notice resource equals TextResource. URI equals resource //notice. Name equals important notice. Text equals system maintenance scheduled for Sunday. Tags equals notification. MCP, add resource, notice resource. #3, using a custom key different from the URI. Special resource equals TextResource. URI equals resource //common notice. Name equals special notice. Text equals this is a special notice with a custom storage key. MCP, add resource, special resource key equals resource //custom key. #4, exposing a directory listing. Data dir path equals path /app data. Resolve. If data dir path is dir. Data listing resource equals directory resource. URI equals resource //data files. Path equals data dir path, #path to the directory. Name equals data directory listing. Description equals lists files available in the data directory. Recursive equals false hash, set to true to list subdirectories. MCP, add resource, data listing resource, #returns JSON list of files.
This demonstrates the resource registration pattern in FastMCP, where static and dynamic data sources are exposed through a unified interface. The pattern treats files, text snippets, directory listings, and even function outputs as first-class resources, each accessible via a unique URI. What makes this distinctive is the declarative approach to data exposure, where you define what's available rather than how it's accessed. The pattern works by decoupling resource definition from consumption. Resources are registered with metadata like names, descriptions, and MIME types, while the framework handles content delivery and client discovery. This separation enables clients to browse available resources dynamically without hard-coding knowledge of the server's data structure. The system supports both static resources, like files, and dynamic ones via functions with the same consistent access pattern. This approach solves the problem of ad hoc data sharing between backend systems and clients, particularly in AI workflows. By standardizing how data is exposed, it eliminates the need for custom API endpoints or file sharing mechanisms. The trade-off is that resources are read-only by design, making this ideal for configuration, documentation, or reference data, but not for mutable state or complex transactions. Let's break it down.
From PassLib, import Path. From FastMCP, import FastMCP. From FastMCP resources, import FileResource. TextResource, DirectoryResource.
Imports the core components for creating AA callable resources. FastMCP handles the server setup, while FileResource, TextResource, and DirectoryResource define the three main ways to expose data: static files, raw text, and directory listings. These are the building blocks for all resource types in the system.
MCP equals FastMCP. Name equals data server.
This initializes the FastMCP server instance named Data Server. This is your central registry for all AA callable resources, handling routing, metadata, and access control for everything you expose. The name identifies this server instance in logs and client connections.
README path equals path /README MD. Resolve. If README path exists.
This resolves the README MD path to an absolute location and verifies its existence before proceeding. Prevents runtime errors from missing files, a defensive pattern when exposing file system resources to remote clients.
Notice resource equals text resource. URI equals resource //notice.
This defines a text resource with a resource //URI scheme, creating a virtual resource identifier. The scheme distinguishes AA callable resources from physical files, while the path, notice, acts as a stable endpoint. This pattern enables consistent resource addressing regardless of underlying storage changes.
Special resource equals text resource. URI equals resource //common notice.
The URI parameter defines a unique identifier for this resource in FastMCP's internal registry. This follows the resource URI pattern where resource // denotes an internal resource, not a file system path, ensuring consistent addressing across different storage backends.
Data dir path equals path /app data. Resolve. If data dir path is dir.
This performs defensive path validation before exposing directory contents. The resolve converts relative paths to absolute, while is dir ensures we only proceed if the path exists and is a directory, preventing runtime errors when the directory is missing. This is the standard pattern for safe file system operations before resource exposure. Resource registration patterns. The direct add resource method and concrete resource classes provide FastMCP's declarative approach to exposing static content, complementing the dynamic at MCP resource decorator pattern. URI keys and storage keys can diverge when using custom keys, creating two distinct identifiers for the same resource. This duality enables flexible resource management without breaking existing client references.
The resource that serves two names becomes nameless to the system that serves all.